Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this series of videos in which I'm focusing on the 2025 year papers actually, there were 9 variants in total. So now I'm focusing on May-June 2025, variant 35, variant 33 and let me focus on differential equations. So there will be one question of differential equation in variant 35 and one in variant 33. So this video will be containing these two questions. Now let me focus on the question that's right over here. That is question number 11. So differential equation, that is like a must question. It's a word problem of integration kind of. The variables x and y satisfy the differential equation x square plus 3 dy by dx e raised to power of 3y x minus 2. Now that is the first thing that I do. That is, this is x, this is x, this is x. That should be on the right hand side. So now over here, this is x, this is x, this is dx and dy and y terms on the left hand side. So 1 over 3 e raised to power of 3y dy. That's on the left hand side. Now the next thing is that you have to simplify out things. So this was easy, just take it up. But this was thought-provoking. If you treat it as it is and you say that the derivative of x square is 2x, derivative of 3 is 0. So yes, x is there, but what will you do with this? So now this is a special scenario in which what we do is that we split the fractions. So now this is about split the fraction. So when we split the fraction, so this is like a minus b over something. That can be written as a over something minus b over something. That is the knowledge that we are using over here. So now over here, the first thing that I did is that this is x over x squared plus 3 minus in the middle 2 over x squared plus 3. Now there are two things that I also did. If this is the denominator, the derivative has to be 2x. So 2 was missing. So that 2 I wrote it myself and I balanced it with a half. That's the first thing. The second thing, that in one of the videos, and of course you have studied, that 1 over x square plus a square dx, when you have to integrate it, so this 3 has to be a square term. So that is the square of root 3. So now let me write two things over here. The technique that I'm using, let me add a page over here and I'm writing two things over here for this thing. So that is one over here. Okay, let me make a proper circle. Sometimes it slips. I don't know what seems to be the issue. Okay, that is good enough. And then this one. Okay. So now the first thing that we need is this thing, integral f prime x over fx dx. That is ln of fx plus c. If the numerator is the derivative of denominator, then the integral is ln of denominator. The next thing is this thing, 1 over x square plus a square dx. This is 1 over a tan inverse x over a plus c. So very important techniques that you need for this particular question, which is question 11. Okay, so now over here, that is the reason why this adjustment is done. So think before you proceed. Now when we integrated e raised to power of negative 3y divided by 3 with a negative sign, this is half ln of x squared plus 3. So now let's highlight each one of them. That is the first one. This is the second one. This is the third one. This 2 as it is. This is 1 over root 3 tan inverse x over root 3 plus a constant of integration c. Now in this question, they are not asking us to make y the subject. It's just asking find the value of y when x is equals to 2, and before that this condition is there in order to evaluate c. So now when x is 3, y is 0. So y is 0 when x is 0, not 3. So e raised to power of 0. This is x square is 0 square plus 3. This is 2 over root 3, that's over here, and 0 over root 3 is 0 plus c. Now over here, tan inverse of 0 is 0, this thing disappears. Half ln 3 remains, e raised to power of 0 is 1, and then we find the value of c as this. So that is c. Now right now it's in the exact form, but later on we have to use the calculator. Because it does not say exact form, that means if it's too difficult, then use a calculator. So now it's saying find y when x is equals to 2. So when x is 2, that is 2 squared plus 3 becomes 7. This is 2 over root 3. This was as it is from before. Now use calculator, take care of accuracy, work in at least 4 significant figures. So half ln 7, that is this thing. So this first red thing over here, this red thing, let me use the marker. So this red thing over here, half ln 7 is this thing. The next one, that is minus, and then 2 root 3 tan inverse 2 root 3, that is this thing. The third one, minus 1/3, I have written correct to 4SF. And then this thing over here, the last one, that is minus half ln 3, that is written like this. So now this 3 and this minus, I took it on this side, I multiply, I get this thing. Now take ln of both sides, e raised to power of minus 3y, this comes down, ln e becomes 1. Take ln of this thing, divide by negative 3, we get this answer, round it off, that is the final answer. Have a good look at it. So now, yes, of course, they won't be giving you marks for free. It's 8 marks. So of course, there is thinking, there is working, there is simplification, there is strategy, everything is over there. Okay. So now this thing is done, and I think the next page is just a blank extra page over here. Let me move up. This is 35. Let me move up, and that is the question over here. So now this is also a differential equation question, and this is May-June 2025 variant 33. So my focus is on 33, 35, nothing special. These two I have paired together. So now over here it says the variables x and y satisfy the differential equation sine 4y dy by dx is x sine 2y sine 3x. The red on one side, the blue on one side. Sine 4y over sine 2y, we know that sine 4y can be written as 2 sine 2y cos y. So what exactly is this? This is the double angle. Sine 4y is the double angle format. That is how this thing is done. And then we know that this sine 2y over here, this sine 2y over here, that cancels out. I'm left with 2 cos 2y. X sine 3x, that has to be done using integration by parts. So this is basic trigonometry, integration by parts. We know the formula u dv, that is u v minus integral v du. That is by parts technique of integration. So now over here, let's focus. That is, this is u, this is du, and this is dv, this is v. Follow the arrows. So now over here, this is u v minus integral v du. So this is u v minus becomes a plus integral v du. This is direct integration. Integral of cos 3x is 1/3 sine 3x. That 1/3 multiplies with this, it becomes 1 over 9. Now the condition, y is pi by 12, x is pi by 2. Y is pi by 12, x is pi by 2. So few things that we need. Cosine of 3 pi by 2 is 0. Sine of 3 pi by 2 is -1. Sine of pi by 6 is half. Sine of pi by 6 is half. Cosine of 3 pi by 2 is 0. Sine of 3 pi by 2 is -1. Simplify, you get c as a fraction form. Sine 2y is this thing. So again, it's not asking us to form an equation or make y the subject. It's just asking a relation between x and y. So yes, it's a relation between x and y. It's an equation. It's a particular solution with the constant of c found. So now the next part, it says, given that y lies between 0 and pi by 2, find the values of y when x is 0. So therefore sine 2y, this is 0, this is 0. Why is it 0? Okay, actually the equation is written over here because there is x over here. This is 0. Makes it 0. Sine of 3x, sine of 0 is 0. That is why we get a 0. That is why we get a 0. Sine 2y is this thing. Now from here onwards, this is basically a trig equation of P1, not even P3, it's P1. The first thing, find the basic angle, that is this thing, work in at least 4SF. Modify the range, y lies between 0 and pi by 2, this is 2y. So this is 2y lies between 0 and pi. So this is like first quadrant and second quadrant. We know that in the first quadrant, theta or y is equals to basic angle, second quadrant y is pi minus basic angle. So now that is the basic angle, this is pi minus basic angle, first write in 4SF, first write in 4SF. Then divide by 2. It's still in 4SF, still in 5SF, at least 4SF, and then the final answer 3SF, 3SF. So that is 33, 35 is already done. So this video, we focused on May, June 2025, differential equations, and we focused on variant 33, we focused on variant 35, more videos coming up soon.